Sorry, so chinna technical issue. So I can continue the second video. Uh, Cannizaros reaction. So this is a Cannizaros reaction. So we know the discuss about the earliest video. So this is the application. So I can take first one. This is a NaOD, sodium hydroxide. So here deuterium is a isotope of hydrogen. It is a strong electrolyte. It is completely dissociated into their respective ions Na plus and OH minus. So here I can take formaldehyde. Okay, formaldehyde. So formaldehyde. So here OH minus act as a nucleophile. So nucleophile attack on where of more electrophilic centers. So oxygen is a partial negative, carbon has partial positive. So that's why electron displacement towards carbon. So we get HCO minus and H and OD. So sorry. So I can write this is a OD. This is also OD. Okay. OD. This is a neutral species. This is a charged species. So generally neutral species are more stable than charged species. So this is the first mole. I can take second mole of formaldehyde. So here this species I can write here H and OD. So here electron displacement towards here this hydride ion H minus shifted to here, electron displacement towards the oxygen. So we get H C H then O minus. Okay, O minus. So and this hydrogen attack on here. So next so we can get another part. This is a hydrogen. Okay, hydrogen. Then this carbon has C double bond O. Then OD. So here this is a conjugate base of methanol. This is the acid which provides the H plus. So that's why D attack on here. So we get a CH3OD. So here CH3OD is there. So here and here this is eliminated. So next remaining part HC double bond O minus, remaining part in the Na plus attack on here. So we get which option? First option is correct one. Okay, first option is correct one. Then okay, then second one. So so this is a formaldehyde. Here concentration NaOH is there. So products are in the. So here first, so I can write NaOH. Done. So this is a strong electrolyte. We know that this is a strong electrolyte. So that's why this is a completely dissociated into their respective ions OH and Na plus, OH minus and Na plus. So I can take first mole of this compound. So this is a D. So our nucleophile is OH minus. So nucleophile attack on where more electrophilic center. This is a partial negative. This is a partial positive. Carbon has partial positive because of it is a less electronegative when compared to the oxygen. That's why electron displacement towards the oxygen. Then carbon gets positive charge. So that's why electron displacement towards here. Electron displacement towards here. So we get HCO minus, then D, then OH. Okay, OH. So this is a neutral species. This is a charged species. So here, which is the most stable? Neutral species is more stable. So that's why which can rearranges. That means which loses the hydride ion. Okay, hydride ion. So here, so I can take second mole C double bond O and D. So this compounds I can write here O minus D and OH. So here Again electron, this is a charge species, electron displacement towards here. So here two possibilities, D minus is leaved or H minus leaved. So which is a easily leaved. So here we know that C bond H and a C bond D. So which is the strong bond? Which is the strong bond? Bond length is directly proportional to mass. So here this is a more mass. Deuterium is a more mass compared to the hydrogen. So that's why here bond length is less. Okay, bond length is, bond strength is a more. So here bond length is less. So that's why hydride ion is leaved. Okay, hydride ion is leaved. Hydride ion H minus, displacement towards carbon, again electron displacement towards oxygen. So we get H C O minus. So already here D is there. Okay, D is there. So H minus. Okay, so remaining part. So here D connected to carbon, carbon connected to double bond oxygen, next to OH. Okay, OH. So here this is a conjugate base. So this is the acid. So acid which provides the proton, this proton attack on here. So this proton attack on here. So we get okay, we get CH2DOH. Okay, we get CH2DOH. So then second one. So here this carbon connected to deuterium. So this carbon connected to deuterium. Okay, so this carbon connected to deuterium. So here any deuterium is there? No. So we will take none of this. Okay, so then so one more question is there. So here this is also formaldehyde. Okay, here also same, sodium hydroxide. Okay, sodium hydroxide, it converts to Na plus and OH minus. OH minus. So here first mole is deuterated formaldehyde. Deuterated formaldehyde. So here OH minus act as a nucleophile. Nucleophile attack on here, electron displacement towards oxygen. So we get D, C double bond O, sorry, C single bond O, C single bond O, C single bond O. Okay, C single bond O. Okay, C single bond O. Then OH attack on here. So then I can take, this is a neutral species, this is a charged species. So general neutral species is more stable than charged species. I can write another mole of deuterated formaldehyde. So I can take this compound D, C, O minus and D, so OH. So here this is an unstable species, that's why this is a rearrangement. So again electron displacement towards here. So deuterium D minus attack on here, electron displacement towards the oxygen. So we get D, C. So here attack on D. So D. So then O minus. So remaining part D connected to carbon. Again electron displacement to yes, double bond O. So remaining part is OH. So this is the first one is a conjugate base. So this is a acid. So which provide the H plus ion. This H plus ion attack on here. So we get a CD3OH. CD3OH. So here CD3OH and CD3OH and CD3OH. So remaining part C double bond O minus. Here Na is there. Okay. So we get, so here H is there, here D is there. This is the correct answer. So D connected to C double bond O. Okay, this is the correct option. So I can take one more example. Okay, so cross Cannizaros reaction. Okay, so one more example, cross Cannizaros reaction. So this is a aliphatic compound, this is a aromatic compound. So we know that, so one compound undergoes to oxidizes, another compound undergoes to reduces. Okay, so if this compound is oxidizes, it converts to alcohol. If this compound undergoes to reduced, it undergoes to alcohol. So which compounds are reduced, which compounds are oxidized? Okay, so stable compound, okay, stable compound undergoes to reduced, unstable compound undergoes to oxidized. So we know that sodium hydroxide is a strong electrolyte, so that's why it completely dissociates into their respective ions, Na plus and OH minus. So OH minus act as a nucleophile. So this nucleophile attack on this compound or this compound. So based on the stability of this compound, so here C double bond O, H, C, so benzene, then benzaldehyde, double bond OH. So here we have one nucleophile is there. So my question is this is a carbonyl compound. This has negative charge. This is a positive charge. So this is also negative charge. This is also positive charge. So here two possibilities there. First possibility and second possibility. Here the nucleophile attack on this compound or this compound. Okay. So where the more positive charge, so that position attack on nucleophile. So here where the more positive charge, okay, where the more positive charge. So here less positive charge. So because of the resonance is there, the plus or affectant. Okay, resonance. And this charge is decreases due to the resonance. So here more positive is there. So that's why electron displacement towards this carbon. Again electron displacement towards here. So we get H, C, O minus and OH minus attack on here, then hydrogen. Okay, then hydrogen. Okay, this is a neutral species, this is the charged species. So neutral species is more stable than charged species, that's why this is a rearranges. So I can take second mole. This is not participate in first step. So this is the participate in the first step reaction. So second one I can take here. So we get C double bond O. Hydride ion shift is there. Again electron displacement towards here. This hydride ion displacement towards oxygen. Electron displacement towards the oxygen. So we get the first compound H, C, double bond O, then OH. So second compound benzene, then C, O minus. So here one hydrogen is there. So next this hydride ion attack on this carbon. So we get another hydrogen O minus. So here this is the conjugate base, this is the conjugate acid which provides the proton. This proton attack on oxygen. So we get first one HC double bond O minus, second one benzaldehyde. This carbon has two hydrogens, then connected to oxygen. This provide the H plus ion. This H plus ion attack on oxygen. So this is a benzyl alcohol. So here O minus, remaining part Na plus is there. This Na plus attack on here. So this is the oxidized product. This is a reduced product. If carbonyl compounds undergoes to reduced, we get alcohols. If carbonyl compounds undergoes to oxidized, we get carboxylic acid. So this is the oxidized product. This is the reduced product. So we know that oxidation. So oxidation means Addition of oxygens. So here how many number of oxygens is there? Only one oxygen. This product 1 and 2 oxygen. That means this is a oxidized product. So this compound. So here addition of hydrogen nothing but a reduction. Okay, addition of hydrogen nothing but reduction. So here how many number of hydrogens is there? Only one hydrogen. So here how many number of hydrogens? Two hydrogens. So that's why this is a reduced product. So what do you mean by the cross Cannizaros reaction? Cross Cannizaros reaction means one is the aliphatic carbonyl compounds, second one is the aromatic carbonyl compounds which can without alpha hydrogen compounds are participate in cross Cannizaros reaction. Okay, so next one more example. Okay, one more example. So here sodium hydroxide is there. Okay, so this is a benzaldehyde. So this is the paramethyl benzaldehyde. So we know that NaOH strong electrolyte. It undergoes to Na plus and OH minus. So here also two possibilities there. Two possibilities is there. C double bond OH. So next to second possibility C double bond OH. So para position which contains methyl group. So here nucleophile is there. Okay, OH minus is there. So this OH minus attack on which compounds? Here partial negative, partial positive. So here partial negative. So because of oxygen is a more electronegative, electron displacement towards the oxygen. That's why oxygen gets partial negative charge. So next carbon gets partial positive. Here also same. So here this is the partial negative, this is the partial positive. So here OH minus ion attack on here, OH minus ion attack on here. So which position is easily attacks? So that decided the here plus I group. Plus I group means electron releasing groups. Electron releasing group decrease the positive charge on carbonyl compound. So that's why here less positive. So that's why this is not possible. This is attack on here. So that means here one oxygen is there, second oxygen. Oxidized product. Oxidized product is okay. Oxidized product is sodium salt of benzoic acid. Okay. So next to second one about reduced product. So reduced product is okay. Reduced product is alcohol. Okay, alcohol. Okay, alcohol. So this is a reduced product. So I can take one more example. Okay, one more example. So here this is a formaldehyde, this is a formaldehyde, but para position is the nitro group is there. So here nucleophile attack on from where? Nucleophile. Here positive charge is there. So here negative. So here positive. Sorry, here negative, here positive. So NaOH, this is a strong electrophile. It undergoes to Na plus and OH minus. OH minus. So OH minus is a nucleophile. Nucleophile attack on this carbon. Nucleophile attack on this carbon or this carbon. Okay. So here two possibilities is there. Where the more positive? So here the more positive because of nitro group is there. Okay, because of nitro group is there. That means OH attack on here. That means number of oxygen increases. So this is the oxidized product. Oxidized product is para-nitro sodium benzoate. Para-nitro sodium benzoate is oxidized product. This is a reduced product. Reduced product is alcohol. So reduced product is alcohol, that is the benzyl alcohol. So benzyl alcohol, this converts to CH2OH. Okay, OH. So I can take one more example. Sorry. Okay, so I can take one more example. Internal Cannizaros reaction. So internal Cannizaros reaction, C double bond ONA. Sorry, just a minute. Just a minute. So this is the internal Cannizaros reaction. That means oxidized and reduced products are obtained in same compounds. So same compound nunchi form ayinante oxidized and reduced product anta. Okay. So here NaOH. So I can write first, I can write mechanism NaOH. This is a strong electrolyte. So that means it completely dissociates into Na plus and OH minus. Okay, OH minus. So here, so I can take mechanism C double bond O H C single bond OH. Okay, so this is a carbonyl compounds without alpha hydrogen. That's why this compound participate in internal aldol condensation. Okay, aldol condensation. So here nucleophile OH minus etacan. This is the OH minus. OH minus etacan, either here positive charge is there, partial negative, partial positive and partial negative. Because of oxygen is the more electronegative, so oxygen partial negative, carbon partial positive, both are same. So that's why anyway the nucleophile attack on any position, so then electron displacement towards here. So we get CO minus and H. So here OH minus is attacked, OH minus ion is attacked, then C double bond O, so H is there. Okay, this is a charged species. Charged species is unstable, so that's why electron displacement towards here. Okay, displacement towards here. Again this hydride ion shift to here, electron displacement towards here. So we get C double bond O. So here OH, then this carbon connected to C connected to hydrogen. So here this hydride ion connected to here. So next to O minus, electron displacement towards oxygen. So this is the conjugate base, this is the conjugate acid. Sorry, this is the acid. Acid and which provide the H plus ion. Conjugate base is strong, so which can accept the proton. So that's why this proton attack on here. Okay, proton attack on here. So we get C double bond connected to O minus. So O minus, here H plus ion is a loose, so that means O minus. Then this carbon has two hydrogens, so then O minus which can accept the proton, it converts to OH. So remaining part here Na plus is there, so Na plus. So this is the internal Cannizaros reaction. Internal Cannizaros reaction means the Cannizaros reaction takes place within the molecule. Okay, so ఒకే molecule లో జరిగింది అనుకోండి, జనరల్ గా internal Cannizaros reaction అంట. Okay, so this is a Cannizaros reaction. Thank you for watching. So this is only for Telugu student. This channel is okay. So వీడియో కానీ నచ్చినట్లయితే షేర్ చేయండి, లైక్ చేయండి, సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ.